Hello everyone, myself Arsha Srivastav, and today I am here to discuss about basic terminology of graph theory. Firstly, we should understand what are graphs. A graph, denoted by capital letter G, is a mathematical structure consisting of two non-empty sets and is written as G is equal to V, E within brackets, where the set V whose elements are also known as vertices, nodes and points of G. This set Vg is known as the vertex set of the graph. The set Eg is known as the edge set of the graph. Both these sets are non-empty sets. So if we consider our first example, we can see here V1 and V2 are the two vertices and E1 is an edge. If we see the second example here, V1, V2, V3, V4 and V5 are the five vertices of the graph, and E1, E2, E3, E4, E5, E6 are the six edges of the graph. Now coming to basic terminology of graph theory. Trivial graph. A graph consisting of only one vertex and no edge is known as a trivial graph. If we consider this example, we can clearly see that here only one vertex is present and there is no edges present in it. So such examples come under trivial graph. Number 2 is null graph. A graph consisting of n vertices and no edges is known as a null graph. If we consider this example, we can see here that there are four vertices present in it and there are no edges in it. If there are no edges in our graph, then our graph will not be formed. So such type of graphs are known as null graphs. Directed graph. So a graph which contains the direction of edges is known as a directed graph. If we look at this example, we can clearly see that each and every edge of this graph has a particular direction, and these directions are represented by these arrows. We can see that E1 is going from V1 to V2, E2 is going from V2 to V3, E3 is going from V4 to V2, and E4 is going from V3 to V4, and E5 is going from V4 to V1. So these are the directions of these edges, and such type of graphs are known as directed graph. And the graph which does not contain any directions of the edges are known as undirected graph. Self loop in a graph. If H having the same vertex as both its end vertices is called a self loop. If we consider this example, we can see that V1, V2 and V3 are the three vertices and E1, E2, E3, E4 are the four edges. If we look carefully at this edge E3, we can see that it is starting from the vertex V3 and it is also terminating at the vertex V3. So this is known as a self loop. An edge which is starting and terminating at the same vertex is called a self loop in a graph. Proper edge. An edge which is not a self loop is called a proper edge. If we consider this example again, we can see that here edge E1, E2 and E4, they are not forming any self loop. So they are considered as the proper edges of the graph. Multi-edge. A collection of two or more edges having identical endpoints are known as multi-edge. If we consider this example, we can see that here V1 and V2 are the two vertices which are connected to each other with the help of these three edges E1, E2 and E3. So E1, E2 and E3 have identical endpoints which are V1 and V2. So the collection of these edges are known as multi-edge. Simple graph. A graph that does not contain any self-loop and multi-edge is called a simple graph. If we look at this example, we can see that this graph does not contain any self-loop and it also does not contain any multi-edge. So such type of graph is known as simple graphs. Multigraph. A graph that does not contain any self-loop but contains a multi-edge is called multigraph. If we consider this example, we can clearly see that this graph does not contain any self-loop, but it has a multi-edge over here. So these type of graphs is known as a multigraph. Now coming to pseudograph. A graph which contains both self-loop and multi-edge is called a pseudograph. If we consider this example, we can see that it contains a self loop and it also contains a multi-edge. So this type of graph is known as a pseudograph. Incidence and adjacency. Let Ek be an edge joining two vertices Vi and Vj. Then Ek is said to be incident of Vi and Vj. Two vertices are said to be adjacent if there exists an edge joining the vertices. If we consider this example, we can see that even is the edge joining the vertices V1 and V3. So even is incidence of V1 and V3. And V1 and V3 are called the adjacency of this edge even. Similarly, V2 and V3 are adjacency of this edge E3, and E3 is incidence of V2 and V3. Same goes for E2. E2 is incidence of V1 and V2, and the vertices V1 and V2 are adjacency of the edge E2. Degree of a vertex. The degree of a vertex V in a graph G written as small d V in brackets is equal to the number of edges which are incident on V with self loop counted as twice. So basically, if we want to calculate degree of a particular vertex, we have to find out the edge connectivity of that particular vertex. So for V1 we can see that it is connected to V3 and V2. So here number of edges is 2, so degree for V1 becomes 2. For V2 we can see that it is having a self loop, so self loop is counted as 2, and it is also connected to V1 and V4. So degree for V2 becomes 4. For V3, V3 is connected to V1 and V4, so degree for V3 becomes 2. Now coming to V4, V4 is connected to V2, V3 and V5, so degree for V4 becomes 3. V5, V5 is connected to V4 and V6, so degree for V5 is again 2. And degree of V6 is also 2 because it is connected to V7 and V5, and degree for V7 is 1 because it is only connected to V6, and degree for V8 is 0 because it is not connected to any of the other vertices with the help of an edge. Now coming to isolated vertex and pendant vertex. A vertex having degree 0 is called an isolated vertex. As you can see in this example here, V8 is an isolated vertex because it is having degree 0, and a vertex having degree 1 is called a pendant vertex. And we can see here that V7 is our pendant vertex because it is having degree 1, because it is only connected to V6, so it is having degree 1 and it is known as a pendant vertex, whereas V8 is not connected to any other vertex, so it is called an isolated vertex. So now coming to finite and infinite graph, a graph with a finite number of vertices as well as edges is called finite graph. Otherwise it is an infinite graph. So if we consider this example, we can see that here number of edges and vertices are finite. And if we consider this example, we can say that here number of edges and vertices are infinite. So this is an infinite graph, and the graph which have finite number of vertices and edges is called a finite graph. As we can see here, this is a finite graph. So now I will be discussing some questions based on the topics which I have already covered in my previous slides. Question number 1 says that which of the following is true for the given graph? So in this question we have to calculate the degree for P1, P2 and P6 vertices respectively. For the calculation of degree, we have to calculate the number of edges which joins that particular vertex to another points or vertex, we can say. So for P6 we can see that it is having a self loop, so self loop is counted as 2 and it is also connected to P1. So number of edges for P6 becomes 3. So degree of P6 is 3. Option A is correct. Degree of P6 is not equal to 2 as I have already explained earlier. Degree of P1 is equal to 2. P1 is connected to P6 and P4. So number of edges for P1 is 2 and degree is also 2. Degree for P2 is 1. This is wrong because our P2 is an isolated vertex and it is not connected to any other vertex through an edge. So this is an isolated vertex and degree for isolated vertex is 0. So option D is incorrect. Question number 2. We have to find the number of isolated vertex in following graph. So we can see that only this point is not connected to any other point. So our number of isolated vertex is 1 in this case. Number 3. Which of the following is a pseudograph? A pseudograph is a graph which contains a self-loop and a multi-edge. So our option A is correct because it is having a multi-edge and it is also having a self-loop. Whereas our option B only has a self-loop and option C has a multi-edge. So both of these options are wrong. With this, I conclude my presentation and these are my references. Thank you.